Let's introduce a new kind of function called an exponential function. The parent function for an exponential function is typically y equals a times b to the x power. A is your initial value, and b is commonly referred to as your multiplier. Let's see a couple of examples. Looking at example 1, I see here is my initial value, and here is my multiplier. So let's go graph f of x. F of x equals 1 times 2 to the x power. So that's mean my y value doubles. So it's going to go from 1 to 2 to 4 to 8, and it'll continue on and on and on. So I'm going to graph my line, making sure to put arrows on the endpoints. Let's talk about the domain and range. Domain is a list of all possible x's. So my domain is all real numbers. And my range is all the y's greater than 0. It does not equal 0. Y will not equal 0 because I have an asymptote at that line. An asymptote is a line I approach but never, ever, ever touch. So in this case, my exponential function will get really, really close to 0, but will never actually touch it. That's why it's the asymptote. So we'll say we have an asymptote at y equals 0. We have no x-intercept, but we have a y-intercept at 0, 1. Our initial value is 1, and our end behavior is as x approaches negative infinity, our y is approaching 0. As our x's are approaching negative infinity, our y value is getting closer and closer to 0. As our x's approach positive infinity, our y's also approach positive infinity. Let's take a look at example 2. G of x equals 8 times 1/2 x. So 8 is our initial value, and 1/2 is our multiplier. Let's go ahead and graph it. Plotting my initial value at 8, and I'm multiplying it by 1/2. It's going 8 to 4 to 2 down to 1, 1/2, 1/4, etc., etc. So I will get closer and closer to 0, but I will never actually touch it. So let's take a look at our domain. Our domain will be all real numbers. Our range is all of the y's greater than 0. We once again have an asymptote at y equals 0, that we will approach 0 but never touch it. We have no x-intercept. We have a y-intercept at 0, 8. An initial value of 8. And our end behavior is as x approaches positive infinity, y approaches 0. As x approaches negative infinity, y approaches positive infinity. If we take a look at our graphs, we can see that they look slightly different from each other. The green one, g of x, is a decreasing function. If you read it from left to right, our y values are decreasing. Our blue function, f of x, is increasing. If you read it from left to right, our y values are increasing. You can tell if a function is increasing or decreasing by just looking at the multiplier. A multiplier greater than 1 means increasing. A multiplier less than 1 means it will be decreasing. Take a look at our final notes page and make sure you have everything written down.